We present a compact cloth state representation that enables generalization across different cloth shapes. Cloth manipulation is hard because of the infinite degrees of freedom of the cloth. To tackle this problem, we propose a compact representation that captures the state of the cloth by using the topological measure degree, which is the directional derivative of the Gauss linking integral. First, we argue that for most folding actions, the border of the cloth is sufficient to determine the state of the cloth for folding tasks. Prior works have built on this idea and have also used the topological measure degree on a few hand-pegged border edge segments to classify a cloth into different cloth states. Building from these prior works, we use all the edges on the cloth border, which gives us more information about the cloth state. We rearrange the degree matrix onto a circular grid. This representation, the degree disk, displays easy to identify features such as the corners, fold locations, and corners that have been folded. The observed pattern is independent of the shape, size, and orientation of the cloth. Following are some examples of how the degree disk changes when folding the cloth. Notice the curve indicates the fold location and inverted corner color indicates the side folded. From the degree disk, we abstract out the corners, the fold locations, and their orientation onto a circle, calling it the cloth state or the closed representation. This representation is compact while maintaining the invariants observed on the degree disk. In addition, the closed representation is also continuous to change in fold location. Observe how the cloth state changes on changing fold location on the close. We can also automatically give semantic labels to the cloth state just by interval reasoning on its closed representation. We can do high and low level planning. Given the initial cloth mesh and the final goal description in the form of close, we can predict the number of manipulation actions needed. When they are in the same semantic region, we can directly move to the goal. However, when in different semantic regions, we need one extra step. For these examples, the manipulation points are chosen such that the resulting trapezoid formed with the fold line has maximum area. Thank you for your attention.